The last lecture we have discussed about the advantages of using a negative feedback in an amplifier. So far we have discussed about how we can achieve gain stability, reduction in the nonlinear distortion and improvement in the frequency response using a negative feedback in an amplifier. Now let's discuss some more advantages of using negative feedback in a transistor amplifier. One is the increase in the circuit stability. The circuit stability means that the output voltage or the gain of the transistor remains constant irrespective of the variations in the ambient temperature or variations in the frequency of the input signal or variations in the input voltage. The parameters which affect the output voltage of a transistor amplifier are this temperature, the amplitude of the input voltage and the frequency of the input signal. So whenever there is a variation in these factors, we know that the output voltage of the amplifier will increase. So this increase in the voltages, output voltages with respect to these parameters will make the distortions in the circuit and which makes the circuit unstable. So we have to make the circuit stable, or we have to make the output voltage constant irrespective of the variations in these parameters by using a negative feedback. Now let's see how a negative feedback attains the circuit stability. For that, let's consider a schematic representation of an amplifier with a negative feedback as shown in this diagram. Let this amplifier as a AC signal source Vs, and this amplifier gives an output voltage of V0 and MV be the feedback fraction of the output voltage which is fed back to the input by the feedback circuit. Now suppose that there is an increase in the temperature. When temperature increases, we know that the transistor parameters like beta, the current amplification will increase. If current amplification increases, it will increase the output current, which in turn increases the output voltage. So or if there is an increase in the input voltage or there is an increase in the input frequency, the output voltage will increase. Suppose the output voltage V0 is increased due to any of the increase in these parameters, then we know that the voltage which is given to the input of the amplifier by the feedback circuit is the MV times the output voltage V0. So this MV into V0 will also be increased. The actual input voltage of the amplifier, that is Vin, is given by Vs minus MV into V0. So when there is an increase in this quantity MV minus V0, this Vin decreases. This decrease in Vin tries to decrease this V0. This when Vin decreases, it will try to decrease the output voltage also. So in this way, the negative feedback tries to ensure a circuit stability. So this is the way we can qualitatively explain a negative feedback circuit attains a more stable output voltage. That means the output voltage remains almost constant independent of the variations in the ambient temperature, the input voltage or the input signal. This input voltage here Vin means it is actually the signal voltage Vs. So we can say that the circuit attains almost a stability when these parameters are changed or increased. Okay.